Good evening, children.
Good evening.
Good evening, Deepthi.
Good evening, ma'am.
All right, so we'll take the introduction to this chapter, lines and angles. As always, we'll not write anything in the class. I'll share the images with you on WhatsApp. So you're just going to listen to me, understand, and wherever you have questions, you can ask and get them clarified. Right. So we'll first see some basic terms used in this chapter. Okay, some basic terms used in this chapter. Point. A point is a location represented by a fine dot. A point is a location represented by a fine dot. So see, point A, point P. So what is this? It's a fine dot. It's a fine dot. And why do we use a point? To show the location of something. Okay, so a point is a location represented by a fine dot. And point is always named using a capital letter. Okay, we use any letter from A through Z, any letter from A through Z, but in the uppercase. Okay, capital letter A, capital letter B. Okay, so point A, point Q. See, this is incorrect. Point D, this is incorrect. This is incorrect because you cannot name a point using a small letter. All right. Okay. It has no dimensions, meaning a point has no length, no breadth, no thickness, no length, no breadth, no thickness. Okay. And this is what I told you. A point is named using the uppercase letters of the English alphabet. It's named using the uppercase letters of the English alphabet. All right. Okay. That's about a point. So example. All right. Okay. Next line. A line has no endpoints. Okay. This is how we represent a line. All right. This is how we represent a line. A line has no endpoints, meaning it extends indefinitely on both the sides, in both the directions. All right. A line has no endpoints. It starts from where? We don't know. Where does it end? We don't know. We don't know both. We don't know the starting point, nor do we know where it ends. Start point, end point, both we don't know. From where the line originates, we don't know. Where does it end? We don't know. So both starting and ending point, we don't know. So a line extends indefinitely on both the sides. It has no endpoints. A line has no endpoints. It extends indefinitely on both the sides or in both the directions. A line is one-dimensional, meaning it has only length. Okay, a line has length, meaning it's one dimension. You can measure the length of a line segment. You cannot measure the length of a line, but it has length. It's one-dimensional. You cannot measure the length of a line. But there is a length. It has length. So it's one-dimensional. A line is one-dimensional. That is, it has only length, but no breadth or thickness. A line is represented with arrowheads in both the directions. So see, with arrowheads in both the directions. This is the arrowhead. Arrowhead in both the directions. All right. A line has infinitely many points on it. Yes, on the line there are infinitely many points. Because the line extends, it goes on in both the directions. So there are infinitely many points on the line. So this is a representation. All right. So a line is represented like this. Now, there are two ways in which you can name a line. You can name this line using a small letter, say line P. You should write it like this here, or you can write it here. You shouldn't see, it's normally not written below. It's written beside, either on the left side or on the right side. So you can write P here, line P. But sometimes if you see it below here, don't think it's a mistake. Okay, line P. It's not written in the middle. Definitely not written in the middle like this. Line P, no. So it's mostly written in the ends. All right, and using a small letter. You can use a single small letter to represent the line. So like this, line L or line M, line N. If you want to use two letters to name this line, then you will have to mark 2 points on it. Mark a point, you can call it P. Mark another point, you can call it Q. Now we know that we use only capital letters, uppercase letters to represent points. So this point P, this point Q, and this is line PQ, like this, line PQ. When you write like this, it is the line segment PQ. A segment is a portion of something. What's a segment? It's a part of something. Segment. Segment means portion. A portion of something. So when we say line segment, it's a portion or a segment of a line. What is a line? A line extends indefinitely on both sides. It goes on and on. A part of it is a line segment. So if you want to name the line, you must say line PQ like this. Look at the board. I said you don't have to write now. Yeah. So line PQ like this. Or if you represent like this is line segment PQ. Line segment PQ. Line segment PQ is only this portion. This you can measure the length. You can use your scale and measure the length of this line segment. Maybe some 7 centimeters. Correct. Yeah. Okay. So see here, there's a dot. You can also use, markings like this. You can also use it's also a dot. It's nothing but a dot there. See, take a point X, another point Y. So line XY. Or if you want to mention the line segment, then it is like this. The symbol is like this, line segment XY. This line segment has a length, has a definite length. You can measure the length of the line segment while you cannot measure the length of a line. So line, we have two ways of naming a line. You can use two capital letters. You can use two uppercase letters to name a line or one lowercase letter to name a line. So you can say line A, or you can say line CD. All right. Okay. So the above line can be written as this. Can you see this here? In the print, you cannot make out the arrow. So there is an arrow. There are arrows on both the sides. All right. So line XY, it is read as line XY. It's written like this and it is read as line XY. This is line. The symbol is line and XY. Okay. The above figure represents line L. See, you can also name a line like this, line L. Is that fine? Line segment. A line segment has two endpoints. You know where it starts and you know where it ends. A line segment has two endpoints. A line segment is one-dimensional. It has only length, no breadth, no thickness. A line segment is represented by 2 points at its ends. 2 points at its ends. For a line, we use arrowheads. On either ends, we use arrowheads to represent a line. Okay. A line segment, we use points. Okay, it starts here, it ends here. Again, this point should be named using a capital letter, say M. This point, any other capital letter, not M again. So say O. So this is MO. Line segment MO. All right. Okay. So it also, now when we say line segment MO, it also means it is the distance between the 2 points M and O. It's a distance. See, there is a point M. There is another point O. When you find the length of the line segment MO, it is the distance between the 2 points M and O. There is a point M, there is another point O. When you find the length of the line segment MO, you are finding the distance between the 2 points MO. M is a point, O is another point. The distance between these 2 points is the length of the line segment MO. Okay. And that's the shortest distance. That is very important. That's the shortest distance. Okay, that it shows the distance, which is the shortest distance, because MO. Okay, if you try to measure the length like this, the distance between, supposing from here you go to your friend's house P, and then you go to O. From this point M, say your friend's house is located at this point M. So from her house, you go to another friend's house and then go to this person's house. Then you will say, I went 4 kilometers here and then say some 5 kilometers, so totally 9 kilometers. But that is not the distance between MO, right? Supposing from M, you go to a point P, and from P, you go to this point O. So totally you have covered, say, 4 kilometers plus 5 kilometers. 9 kilometers. So where were you initially at M? Now where are you? Which is your final position? O. What's the total distance you have covered to reach this point O from M? 4 plus 5, 9. But that is not the distance between M and O. That's not the distance between M and O. So the length of the line segment MO is the shortest distance. So what is the shortest distance? From M, if you want to go to O, you should take this path. Yeah, so that's what you see here. A line segment is the shortest distance between any 2 points. A line segment is the shortest distance between any 2 points. All right. Okay. Yeah, the above line segment can be written as line segment AB. And it is read as line segment AB. This is line segment. There's a symbol which is read as line segment, and this is AB. AB, line segment AB. Ray. A ray has, let's read all this once again. Line segment. A line segment has 2 endpoints. A line segment is one dimensional. It has only length, no breadth, no thickness. A line segment is represented by 2 points at its ends. A line segment has a fixed length. It has a fixed length. A line segment is the shortest distance between any 2 points. All right. A ray has an initial point and extends indefinitely in another direction. Okay. So say this is the initial point of the ray. So this is ray OA, ray OA, ray OA. This point is O, this point is A, and this symbol, see here, a point and an arrow. Point on one end, arrow on the other end. Okay, and OA 100. So ray OA, ray OA. Yeah, ray. Okay, so ray OA. So when we say ray OA, it is from here the ray starts and extends indefinitely in the other direction. So a ray has an initial point and extends indefinitely in another direction. A ray is one dimensional. Okay. A ray is represented with a point on one end and an arrowhead on the other end. Right? A ray is represented with a point on one end and an arrowhead on the other end. Correct? So you can see here. This is what I had shown you earlier. Okay, we said ray OA, right? Ray OA. That's what you see here. Ray AB. You can see the point here, arrowhead here. AB, ray AB. ray AB. So this is the point. This is the arrowhead. Ray AB. It is read as ray AB. Okay. Now, ray AB is different from ray BA. Ray AB is different from ray BA because when we say ray AB, the initial point is A and it extends in this direction towards B. But when we say ray BA, the initial point is B and it extends in this direction towards A. I repeat, ray AB is different from ray BA. Is different from ray BA. For ray AB, A is the initial point. For ray BA, B is the initial point. Ray AB, which is the initial point? A. Ray BA, the initial point is B. So here in this figure, the initial point is A and the ray extends indefinitely in the direction of B. But here B is the initial point and the ray extends indefinitely in the direction of A, towards A. Okay, so ray AB is different from ray BA. They're not the same. But when we say line segment or line, it's the same. Now, when you say line PQ or line QP, it's the same. Line PQ, line QP is the same line. When we say line segment XY or line segment YX, both are the same. Line segment XY is the same as the line segment YX. Only in the case of a ray, it's different. Ray AB is different from ray BA. Ray XY is different from ray YX. We've seen three terms, right? Line segment, and ray. For line and line segment, AB, BA, both are the same. PQ, QP, both are the same. It represents the same line or the line segment. But in the case of a ray PQ is different from ray QP because the initial point is different. Okay? Okay. Collinear points. Collinear points. Now, when can we use this term collinear points? Only when you have three or more than 3 points. The term collinear points is not used for 2 points. 3 or more than 3 points, not 2. 3 or more than 3 points. This term collinear points, okay, cannot be used for 2 points. When you have 2 points in a plane, you cannot use this term collinear points. 3 or more than 3 points are said to be collinear if they can be connected by the same straight line. Now, these 4 girls, okay, they're collinear because they're sitting in the same straight line, right? The 4 of you. Now, these 2 boys, I can't say they're collinear because only 2 boys. No. Because 2 boys, however they sit, they can be connected by the same straight line. 2 things, however you sit. See, I sit here and another person, wherever that person sits, we can be connected by the same straight line. 2 people. See, one person is here. The other person, wherever that person sits, here or here or here, you can connect the 2 people by the same straight line. But so for these 2 boys, I can't say that they are collinear because they can be connected by the same straight line. They'll always be collinear. Even if Harshit is tired of Santosh and he runs away and he sits in the last row, still we can connect them by the same straight line. But if one of you dislocate, okay, so now, what's your name? Pranava, yeah, Pranava. Pranava and Tanya, they have some disagreement. So, she gets wild and she changes her place. She goes to the row behind. Then, can I connect the 4 of you by the same straight line? No, it'll be a broken line, right? Because as of now, Satakshi is here, Pranava is here, Tanya is here, Akshay is here. So now the four girls can be connected by the same straight line. But now who gets upset? This girl gets upset. So what she does? She goes here. But the rest of them stay here because the disagreement is only between these two. So she dislocates. She goes behind. So now how will you connect them? Like this, not collinear. If there are 4 points, all of them should be, you should be able to connect all of them using the same straight line. Okay. So now supposing there are only 3 girls. Okay. So now these two people talk. Again, some disagreement. My answer is right. Your answer is right. I finished first. You finished first. You didn't say hi to me. Okay. Okay. So for some reason, again, they have a difference in opinion. So what this girl does, she sits here. So now again, see 3 girls. No, see connect. No, you are not able to connect them by the same straight line. It's a broken line. No, so it has to go like this and then like this. Yeah. So 3 or more than 3 points are said to be collinear if you can connect them by the same straight line. You start and you keep going like this. Okay. If you're able to connect all the 4 points or all the 3 points by the same straight line, then the points are collinear. Otherwise, they're not collinear. 3 or more points, or you can say 3 or more than 3 points are said to be collinear if they lie on the same straight line. That's what I meant. So if they can be connected by the same straight line or if they lie on the same straight line. All right. Correct. Yeah. So you can see here the points A, B, C, they are collinear because they lie on the same straight line. Non-collinear points. So you understand the points M, N, O, P, and Q, they're not collinear. How many points? 1, 2, 3, 4, 5. So these 5 friends, they're not able to get along at all. So they all sit in different places like this. Okay. So see, not collinear. But M and how you can connect. See, when when we have 5 points, we are talking about all the 5 points. You cannot take 3 out of them. When you have, yeah, when we have 5 points, we are talking about the collinearity of all the 5 points. So these 5 points are not collinear because they cannot be connected. They are not able to be connected by the same straight line. Is that fine? In the figure, points M, N, O, P, and Q are non-collinear points. They are non-collinear points. 3 or more points are said to be non-collinear if they do not lie on the same straight line. If they lie on the same straight line, collinear. If they do not lie on the same straight line, they are non-collinear. And the term collinear cannot be applied to 2 points because 2 points you can always connect them by the same straight line. They're all, yeah, we can't say the term, but yes, you're right. You can still connect them, yeah. So it's not for 2 points. It's always for 3 or more than 3 points. Angle. So when is an angle formed or how is an angle formed? Okay. See that here. So when two rays meet, an angle is formed. See, supposing you have a ray like this, another ray like this. Okay. So these 2 rays, they have the same initial point. The 2 rays meet. Okay. Yeah, an angle is formed. An angle is formed when 2 rays have the same initial point. When 2 rays have the same initial point, an angle is formed. Okay, so here are 2 rays, OP and OQ. OP is a ray, right? OQ is another ray. Why are they rays? Because O is the initial. Why are they rays? Because O is the initial point, and this ray extends indefinitely in the direction of P. Here, O is the initial point, and this ray extends indefinitely in the direction of Q. So OP and OQ, they're rays because they have an initial point, and they extend indefinitely in the other direction. So they are rays. So when 2 rays have the same initial point, an angle is formed. So this is the angle. This is the angle. Correct. Okay. Ray OQ starts from O. Ray OP also starts from O. Like the rays of the rays emerging from a bulb when it is turned on. You turn on a bulb, you know. So there are so many rays emerging from the bulb, but they all go in different directions. But they all start from the bulb. The rays, all of them, they start from the bulb, right? All the rays originate from the bulb, but they go in different directions. So like that. So they have the same starting point, but they all go in different directions. Now this one is called the, this point O is called the vertex of the angle. Vertex of the angle. Okay. O is called the vertex of the angle. And how do you name this angle? You call it angle O, because the angle is always formed at the vertex. The angle is always formed at the vertex. So you can call it angle O. Or if you want to name it using 3 letters, it is angle QOP or angle POQ. Yeah, very good. O should be in the middle. O should be in the middle. Because O is the vertex. And that's the point where the angle is formed. Okay, so that letter O should be in the middle. So you can simply say angle O. Or if you want to use 3 letters, angle QOP or angle POQ. And this is the symbol for angle. Angle. And you write the name of the angle inside this. Sometimes children write like this, angle QOP. Well, I don't write like this. I write like this, angle QOP like this. But I don't know how it looks when I type it in Word. Let me see, how does it look? Okay, see here, angle A, angle B. When I write, I'm saying when I write, I always write like this, angle AOB like this. It's not angle AOB like this. Well, I think if your teacher writes like this, you will also get used to writing like this, but I'm used to writing it like this, right? An angle. An angle is formed when 2 rays originate from the same endpoint. An angle is formed when 2 rays originate from the same endpoint. See, and now you'll be confused. What are you saying? Endpoint. Both of them are ends. No, either sides are called the ends. This is one end, that's the other end. So don't get confused. Like, why she say, why is it same endpoint? Endpoint, see, both the sides are endpoints, right? This is an endpoint, that's also an endpoint. Both the sides. So an angle is formed when 2 rays originate, that when 2 rays start from the same endpoint, Yeah, when an angle is formed when 2 rays originate meaning start from the same endpoint. So here the endpoint is O. From the same point, these 2 rays originate or they start. From this endpoint O, both these rays start or originate. So an angle is formed. The rays are called arms of an angle. So this one and this one, the 2 rays, OA, ray OA and ray OB, they are called the arms of the angle, Okay. And the common endpoint is called its vertex. The common endpoint, this one, the common endpoint is called the vertex. The rays are the arms of the angle. Okay, so these are the parts of an angle. So when you talk about an angle, you can point out to its vertex. Okay, so which is the vertex? It's the same endpoint from where the 2 rays originate. It's the same endpoint from where the 2 rays originate. And the angle is formed at the vertex. The rays are called the arms of the angle. The 2 rays are called the arms of the angle. Okay. So you can see it in the figure here, okay? This is the angle, arm, vertex. All right. Complementary angles. Now 2 angles, again, complementary angles. You can use the term complementary angles only for a pair of angles. For exactly 2 angles. 2 angles are said to be complementary if their sum is 90 degrees. Not 3 angles, not 4 angles, not 1 angle. Exactly two angles. If the sum of two angles is 90 degrees, okay, there are two angles. You find their sum. It's exactly 90 degrees. Then the two angles are said to be complementary angles. One angle is said to be the complement of the other. For example, 60 degrees and 30 degrees. We have two angles, exactly two angles. We have 60 degrees, 30 degrees. What is 60 degrees plus 30 degrees? 90 degrees. The sum of these two angles is equal to 90 degrees. So 60 degrees and 30 degrees are said to be complementary angles. They're called complementary angles. 60 degrees is the complement of 30 degrees and 30 degrees is the complement of 60 degrees. See here, if three or more than three angles add up to 90 degrees, they are not called complementary angles. If there are three angles, 10 degrees plus 50 degrees plus 30 degrees, 90 degrees. So you can't call these three angles complementary angles. The term complementary is not applied for three or more than three angles. It's for exactly two angles. It's exactly for two angles. Correct. No, they're not complementary angles. So see, supposing you have two angles, 90 degrees and 0 degrees. 0 degrees is zero angle. Zero angle measures 0 degrees and 90 degrees. The sum of these two angles is 90. So these two angles are complementary. 0 degrees is the complement of 90 degrees. 90 degrees is the complement of 0 degrees. 90, these two angle measures, 90 degrees and 0 degrees, they are complementary angles. Okay, with no second thought, the angles 90 degrees and 0 degrees, they are, because 0 degrees is the zero angle. 90 degrees, we know, right angle. Remember, right angle? No? Okay, yes.
Right angle means that will be 90 degrees.
Correct.
Like this.
Correct. All right, yeah. So 90 degrees and 0 degrees, they add up to 90 degrees. So these two angles are complementary angles. 90 degrees is the complement of 0 degrees and 0 degrees is the complement of 90 degrees. Yeah. Can two acute angles be complement to each other? Think and answer. Can two acute angles, Deepti, can two acute angles be complement to each other? Just take an example, that's all. See, think means not like this, think what can be the answer, not like that. Take examples, take two angles, take two acute angles. Now, let's say 25 degrees and 65 degrees. Both of them are acute, right? What are acute angles? If their measure is less than 90 degrees. If their measure is less than 90 degrees, they are acute angles, right? Now, what's the sum? 25 degrees is an acute angle. 65 degrees is also an acute angle. What is their sum? 90 degrees. Yeah. Yeah, so they can be. Yes. You should just give an example. You don't have to write theory for this. You should say, consider the angles 25 degrees and 65 degrees. Both of them are acute, no? So consider the angles 25 degrees and 65 degrees. 25 plus 65 is equal to 90. So yes, we can have two acute angles which are complements of each other.
Ma'am, but two acute angles cannot be a complement to each other.
Correct. The second one can two obtuse angles. What is an obtuse angle? Whose measure is more than 90. It
Can be.
cannot or can? Cannot, right. Two obtuse angles cannot be complementary angles because one angle itself will be more than 90 degrees, right? Each of the angles, not one angle, each of the angles will be more than 90. Then their sum will be more than 180. What are obtuse angles? Angles which measure more than 90 degrees. So one angle is greater than 90 degrees. The other angle is also greater than 90 degrees. So when you add, you will get a sum greater than 180 degrees. When you add, you'll get a sum greater than 180 degrees. So they're not complementary angles. Can two right angles be complement to each other? Can two right angles? No. So 90 degrees and 90 degrees? No. Right? Because their sum is 180. So how do you check if they're complementary angles? Should find the total. If the sum of the two angles is 90 degrees exactly, not 89.5. Okay, you should strictly, get the sum 90 degrees. No lenience there. It was 89.99. So I said, yes, they are complementary. No, no, no. Exactly 90 degrees. You must get exactly 90 degrees. Okay. So two right angles cannot be complement of each other because 90 plus 90 is 180. So that's what you'll see here. Okay. Yeah. Which pairs of angles are complementary? Just mention 1, 2, 3, 4. Use the numbers. Only one, na?
One. Then I copy everything in the record.
Yes. No, no, no. Don't write anything. I told you, no, today's class, you're not writing anything. I'll share the notes with you. No, I think. Add. Yes, Deepthi?
Ma'am, only number 1 is complement.
Only one. Okay, only the first one. Okay. 70 plus 20 is 90. What is 75 plus 25? 100. What's 48 plus 52? 100. 35 and 55? Deepthi? Did you check 35 and 55?
Ma'am,
should not. 1 and 4. 1 and 4. Okay, 1 and 4. Oh, you're not able to. Okay. 70 plus 20, 90. 35 plus 55, 90. Here, 52 and 48, 100. 75 and 25, 100. So these two, no. Complementary angles. Yeah. Yeah, I'll give you a minute's time. Get the answers for A, B, C, D. Correct, yeah.
I'm asking that 90 minus 45.
Correct.
First one, 45.
You must write the complement of 45 degrees is 90 minus 45, which is 45 degrees.
Yes, ma'am. Next one.
Yeah, tell me.
The complement of 65 degree is 90 minus 65 equals to 25 degrees.
25 or 35?
35.
Next one. For 41 degrees.
No, 60.
For
65 degrees.
65 can be 24.
Yes.
90 minus 65.
If they could given the 5, they have the answer 50 and the answer 50 with 5. They gave 5 there and answer to be also 5.
90 minus 65. 25.
Yeah.
The complement of degrees is 90 minus 65. Why am I writing 3? 25 degrees. Yeah, next one. 49 degrees. Next one. 30? Correct. So you can fill up the complement of 41 degrees is 90 minus 41, which is 49 degrees. Correct? No, you don't have to write anything now. I just asked you to subtract and find the answer. That's all.
Right.
Situations like this we'll take up later, okay? Because for this I need to do a little of linear equations. I'll just take some 8 situations from linear equations. So we'll take up this question later. Supplementary angles. Two angles are said to be supplementary angles if their sum is 180 degrees. If their sum is 180 degrees. You can see here 60 degrees, 120 degrees. 120 plus 60 is 180 degrees. So the two angles are supplementary. So again, like complementary angles, supplementary angles is only about two angles, exactly two angles, not more than two angles. The sum of the two angles should be exactly 180 degrees. Then they are supplementary angles. 100 plus 80, 180. So you see here, if three or more than three angles add up to 180 degrees, they are not called supplementary angles. All right? Yeah. Use the last page of your book to do some rough calculation to answer these questions.
Can you go to the last page?
Can two obtuse angles be supplementary?
Yes. No, obtuse and obtuse mixed only can be some.
Correct.
Last year it was.
Thank you. So two obtuse angles. That means both of them will measure more than 90 degrees. So the sum will be more than 180 degrees. See, maximum is 90-90. Like if both the angles are more than 90, if both of them are more than 90, then the sum will be more than 180. See, just add 91 and 91. No, just take a little more than 90. 91 degrees. 91 degrees is an obtuse angle. 91 degrees is an obtuse angle. Even if you take 90 for this, you will still get 181. So a combination of an obtuse angle and a right angle itself cannot be supplementary. This is a right angle. This is an obtuse angle. This combination itself cannot be supplementary. Two obtuse angles. That means more than 90 degrees, more than 90 degrees. When you add, the answer will be more than 180 degrees. This is the symbol, no? Greater than. Yeah. Two obtuse angles. Greater than 90, greater than 90. So the sum will be greater than 180. So two obtuse angles cannot be supplementary angles. Two acute angles. Both are less than 90. Both are less than 90. So when you add, the total will be less than 180.
So
when you take two values, less than 90, both of them are less than 90. So when you add, the total will be less than 180.
I think, yeah, right. Complementary.
Yeah, two acute angles can be complementary, not supplementary. So two acute angles. So see, like is 89 acute? Yeah, it's less than 90. We'll take another 89. What's the total? 9, 9, 18, 1 carried over, 178. Two acute angles means what? Their measures is less than 90 degrees, right? Two acute angles, both are less than 90. So when you add, the sum will be less than 180 degrees. So two acute angles cannot be supplementary angles because less than 90. Why am I saying less than 90? Because acute. So less than 90, another angle less than 90. When you add, the sum will be less than 180. They cannot be supplementary.
The last one then.
What about, can two right angles be supplementary? Right angles. Yeah. Two right angles. Two right angles means 90 degrees. Right angle.
The sum will be 180. So this is something.
The measure of a right angle is exactly 90 degrees. The measure of a right angle is exactly 90 degrees. So 90 plus 90, 180. Yes. Can one acute angle and one obtuse angle be supplementary? Yeah, take an example. 100 degrees is obtuse.
80 degrees is something. Oh, no.
All right. One acute angle. Take any acute angle, let's say 10 degrees. And one obtuse angle, 170 degrees. Yeah, 180. 170 is obtuse. It's more than 90, but less than 180. It's obtuse. And 10 degrees is acute. It's less than 90. Yes, a combination of an acute angle and an obtuse angle can be supplementary angles. Right? So we'll just see it again. When you take two obtuse angles, that is two angles greater than 90 degrees. Two obtuse angles, both of them more than 90. The sum will be more than 180. So not possible. Two acute angles. Acute means less than 90. Both are less than 90. Acute means both are less than 90. So the sum will be less than 180. Less than 180, they are not supplementary. Next one, two right angles. Yeah, 90 and 90, 180. Yes. One acute and one obtuse. Yes, this is obtuse. This is the acute. Yeah, they are supplementary. You can give many examples. Yeah. Find the pairs of supplementary angles. Yes, Satakshi is the in the first figure. Are the angles? No. The second one? No. Third one? Fourth one?
Fourth one cannot be a complement.
Correct. In the fourth one, 45 plus 45 is 90. The two angles are complementary, not supplementary. The third one, yes, 180. 130 plus 50 is 180. They're supplementary. Second one, the sum is 170 degrees. So they're not supplementary. And the first one, the sum is 160 degrees, not supplementary. So you must write the supplement of 100 degrees is 180 minus 100, which is 80 degrees. This is how you present the answer.
For the second number, 190. Not for the second one also 90.
Yeah, the second one is 90.
Second also. When the third one's answer is 125 degrees.
Correct.
Now the last one's answer is 55 degrees.
Correct. 55. All right. Yeah. Okay, so the next term is adjacent angles. Adjacent angles. So far we have discussed about rays, lines, line segments. Correct. Collinear points, non-collinear points,
Angles,
supplementary angles. Very good. Very good. Yeah. Rays, lines, line segments. Point. We forgot point. So we started with point. Point, ray, line segment, angle. Okay. All right. Okay. So point, line segment, ray, angle, collinear points, non-collinear points, angle, complementary angles, supplementary angles, now adjacent angles. Adjacent angles. Now, adjacent angles is about two angles, like complementary angles, supplementary angles. Adjacent angles are also only about two angles, not more than two. See, two angles are said to be complementary if their sum is 90 degrees. Two angles are said to be supplementary if their sum is 180 degrees. Similarly, two angles, when we say adjacent angles, we are talking about only two angles, exactly two angles. Now, when are two angles called adjacent angles? When are two angles called adjacent angles? Okay, so we'll see that. I'll just take a figure. Name the rays. Name the rays you see in this figure. Name the rays. OA, OB, OC. Now these three rays have the same end point, right? They originate from the same end point, right? The three rays, they originate from the same, they start from the same end point, which is that O. Okay. So the three rays, they originate from the same endpoint O. Okay, that's one thing. Okay, adjacent angles must have the same vertex. You see, you guys are distracted. Okay, all right. So adjacent angles must have the same vertex. So here you can see how many angles can you see here? Name the angles. Name the angles. Name the angles you see in this figure. Very good, very good. So you can see angle AOB, also called angle BOA. You can see angle BOC, also called angle COB. And you can also see angle AOC or angle COA, also called angle COA. Can you see any other angle here? See, this is say angle 1, this is angle 2, and this whole thing is angle 3. That's all. We have only 3 angles here. In this figure, you can identify only 3 angles. Angle 1, which is this one, angle AOB or angle BOA. Angle 2, which is angle BOC or COB. And angle 3, which is angle AOC or COA. Am I right? So in this figure, you can see only 3 angles. Yes, Tanya. Yeah, you want to think for some time? Okay. AOC. When you say angle O, you're talking about the whole angle, which is angle AOC. When you simply say angle O in this figure, in this figure, actually, when you say angle O, you're not being specific because at the vertex O, there are three angles. Which O are you talking about? Are you talking about the O, which is angle 1, or O, which is angle 2, or O, which is angle 3? Because at this vertex, there are three angles. So in this situation, you need to be specific. So you have to use 3 letters to name the angle. In such a situation, see, if in this figure, you can just say angle O. Because at this vertex, only one angle is formed. So there is no question of which is the angle O. There's only one angle here. So when you say angle O, it is this angle. You can also say angle AOC or COA. But in a figure like this, where more than one angle is formed at the vertex, you should be specific. That is, you should use 3 letters to name the angle. Okay. So far, fine? Yes. Name the rays. You all said OA, OB, OC. Name the angles. Okay. So how many angles are formed at the vertex O? 3 angles. 3 angles are formed at the vertex O. These 3 angles are angle 1, angle 2, and angle 3. Correct? Okay. Now, the 3 angles are formed at this point O. Okay. Now, name the arms of the angle. Name the arms. 1 minute. I'll just write. I'll be specific. Arms of angle AOB. Name the arms of angle AOB. Arms are rays. Arms are rays of rays. So arms of angle AOB. Ray OA and ray OB. Yes or no? Okay, and an angle has 2 arms. The 2 arms are the 2 rays. So angle AOB, from the name itself, you can make out, no? Angle AOB, right? So OA and OB. O is the starting point. So OA, OB. You can see here, OA, OB are the 2 arms of angle 1. Which are the arms of angle BOC? Ray OB and ray OC. Ray OB and ray OC are the arms of angle 2. Correct? Okay. Now these 2 angles, do they have a common arm? In and no. Do these 2 angles have a common arm? Look at that and tell me. Which is the arm that's common? Ray OB. These 2 angles have a common arm. Which are the non-common arms? The common arm is OB. The common arm is OB. Ray OB is the common arm. See here, common arm OB. Which are the non-common arms? This one and this one. These were the non-common arms. Now, where are the non-common arms? Are they on either sides of the common arm? See, OB is the common arm. OB, this is the common arm. This is the common arm. Where are the non-common arms? They should be on either sides of the common arm. They should be on either sides of the common arm. So you can see here, OA is above the common arm OB. And OC, look at the board. The common arm is OB. Okay. Now, where is this arm or ray OA? It's above the common arm. And where is this arm or ray OC? It's below the common arm. Which means the non-common arms are on either sides, on other, like left side, right side, above, below, on either sides, opposite sides of the common arm. So, if 2 angles have a common vertex, if they have a common arm, and if they're non-common arms, lie on either sides, opposite sides of the common arm, then the two angles are called adjacent angles. All these three conditions must be satisfied. We'll see it again. The three conditions are, if you have to call two angles adjacent angles, then the two angles must have a common vertex. Now there are two angles. You have to identify if the two angles can be called adjacent angles. See, how will you identify if two angles can be called complementary angles? You'll find their sum. If it's 90, you will say they're complementary. If the sum is 180, you will say they're supplementary. So like that, how will you check for adjacent angles? You should check for these three things. What are the three things? The two angles must have a common vertex. The two angles must have a common vertex. Next, the two angles must have a common arm. Next, the non-common arms must lie on either sides, on the opposite sides of the common arm. If all these three conditions are satisfied, then the two angles are adjacent angles. So which two angles? Angle 1 and angle 2. Angle 1 and angle 2. So angle 1 and angle, in this figure, angle 1 and angle 2 are called adjacent angles because they have the common vertex O, common arm OB, and their non-common arms OA and OC lie on either sides of the common arm OB. So we have to check if this angle and this angle, if these two angles, we'll have to check if this angle and this angle are adjacent angles. Okay. So what is angle 1? Angle 1 is angle QPR, right? QPR or angle RPQ. And what about angle 2? It's angle RPS or angle SPR. Now, we have to check if angle 1 and angle 2 can be called adjacent angles. Okay, so let's check. We'll see if they have a common vertex. Okay, which is the vertex of the two angles. You can see from the name, the vertex P. See here, P. That letter P is in the middle, no? Yeah, so P is the vertex. The two angles have the same vertex P. Because where is the angle formed? The angle is formed at P, right? The angle is formed at P. Angle 1 and angle 2, both the angles are formed at P. Yes or no? P is the common vertex for the two angles. See, when you name the angles, can you see the letter P in the middle? Yeah, that means the common vertex is P. Okay, common vertex P. So they have the same vertex P. Then tell me the arms of angle 1. Which are the arms of angle 1? Arms are rays.
Ma'am, ray PQ and ray PR.
Ray PQ and ray PR.
PR.
And what about for angle 2? PR and
PR and PS.
PS. Okay, so here we have the arms of the two angles. Now, these two are the arms of angle 1. These two are the arms of angle 2. Now, check, do they have a common arm? Okay, so common vertex is P. Common arm is ray PR is the common arm. Now, look at the non-common arms. This one and this one are the non-common arms. These are the non-common arms. Where is PQ? It's here. Where is PS? It is here. Where is the common arm? It's here. The common arm is here. And these are the non-common arms. Yeah, the non-common arms, they lie on opposite sides of the common arm. They don't lie on the same side of the common arm. One is on this side, one is on the other side. Okay, so all the three conditions are satisfied. So angle 1 and angle 2 are adjacent angles because they have a common vertex, they have a common arm, and their non-common arms lie on either side of the common arm. Two angles are said to be adjacent angles if they have a common vertex, a common arm, and their non-common arms lie on either sides of the common arm. All right. Yeah, go through this. Don't read aloud, just read for yourself.
Done, ma'am.
Yeah, good. Okay.
After the big option, after a common arm, and then you put the hand. After that is there anything for the hand?
Very good question. So Harshit is asking me, why have I put an and here and there is nothing after that? Have I missed to write anything or missed to type anything is this question? The word and here is very important because all the three conditions must be satisfied. They must have a common vertex. I should put a comma here. Then I think it will make more sense. They should have a common vertex, a common arm, and their non-common arms. And their non-common arms lie on either sides of the common arm. Meaning all these three conditions must be satisfied. And okay. எனக்கு தெரிஞ்ச மாதிரி நான் பிரசன்ட் பண்றேன். நீங்க இன்னும் பெட்டரா பிரசன்ட் பண்ண முடியும்னா பண்ணுங்க. I'll be the happiest. It'll look like a paragraph. So I just put it in A, B, C because these are three conditions and all the three conditions must be met. All the three must be satisfied. Okay, so they have a common vertex, comma, a common arm, and all the three, and their non-common arms lie on either side of the common arm. All right. Yes.
First one is like the first one, fourth one, and fifth one are the right. 1 to 4, right?
Are the angles marked 1 and 2 adjacent? If they are not adjacent, say why. Yeah. Very good. Yeah. In three, angle 1 and angle 2, they are not adjacent because they have different vertices. This is the vertex. This is the vertex of angle 1. This is the vertex of angle 2. Angle 1 and angle 2, they have different vertices. So in figure 3, angle 1 and angle 2 are not adjacent angles. Correct. Very good.
And the second one, that is the common arm. I can tell. But it does not follow there is only one angle. See that? It should not be like that. It should not be like that.
இல்ல ஒரு நிமிஷம். இல்ல இது yeah. Yes, Deepthi. Yes, Deepthi.
Ma'am, in number 2, both the non-common arms are not lying after the common arm.
It is no, see, one arm is on this side, the other arm is on this side. This is the common arm. They are lying on either sides. See, this is the point from where the rays start. Okay, this is the common vertex. This is the common arm. These are the non-common arms, and they are on either sides of the common arm, no? So in figure 2, angle 1 and angle 2 are adjacent angles because this is the common vertex. This is the common ray. What are you doing? Excuse me. What are you doing? What? Nothing. What was that action? Yeah, tell me, Santosh.
Even if it is a straight angle, it can be an
Yes, yes. Yeah, yeah. So in figure 2, figure 3, Shivani told us that they are not adjacent angles. Angle 1 and angle 2 are not adjacent angles because this is the vertex of angle 1 and this is the vertex of angle 2. They have two different vertices. So, but what is the condition for adjacent angles? They must have a common vertex. That itself is not satisfied. So don't check the others. Don't check if they have common arm. Don't check if the non-common arms are lying on either side. Don't check. All the three conditions must be satisfied. The first one itself is not satisfied, then that's all. They are not adjacent angles for figure 3. In figure 2, this is the common vertex. This is the common vertex. This is the common arm, right? And these are the non-common arms. And they are on opposite sides of the common arm. So yes, yes for this also. Yes for this also. What about this one? Angle 1 and angle 2? Yeah, no, it's correct. Marking is correct. Marking is correct. This is angle 2 and this is angle 1. Are these two angles adjacent angles? The marking is correct. This is angle 1. This is angle 2. No, this is 1. This is 1. This is angle 1. And this one is angle 2. Yeah? They are adjacent angles. Okay. Yes, sir. Okay, let's do the fourth one together. Okay, let me name the angles. Okay, let me call this point O, A, B, C. All right. Okay. Now we are talking about, or we are checking if angle 1 and 2 are adjacent angles. So tell me the vertex for angle 1. Vertex for angle 1. O. Vertex for angle 2. O. O. Okay. Arms of angle 1.
O, A.
OB, OC. Angle 1.
OBOC.
OBOC. Ray OB, Ray OC. Arms of angle 2. எப்படிமா AOOB? Angle 2 எங்க இங்க வரைக்கும்? Angle 2. This is
OEOC. Ma'am, they are not adjacent.
OB இல்ல. See here. OAOC. OAOC. See, this is the angle 2. Angle 2 is this one from here to here. Which are the two arms it is touching? It's touching this one, OA, and it's touching this one, OC. OAOC. That angle, when you mark, no, it will touch two rays, no? Those two rays are the arms. When you mark that angle, it will touch two arms. It will touch two rays. They are the arms. See, when you mark like this, see.
Ma'am, it's not adjacent.
Okay, all right. See, Harshit, when I mark angle 1, this is angle 1, no? See, this marking is touching two rays, no? It's touching this ray and it's touching this ray. Yes or no? So they are the arms of angle 1. Yeah. So Harshit, tell me the arms of angle 2. Ray OA, Ray OA, and Ray OC. Correct. Now check if they have a common arm. Check from this. See, we have, these are the four arms, OB, OC, OA, OC. Do they have a common arm? Ray OC. This is the common arm. This is the common arm. Common arm. Okay. So we have mentioned the vertices. Vertex for angle 1, O. Vertex for angle 2, O. So they have a common vertex. Vertex for angle 1 is O. Vertex for angle 2 is also O. So the two angles have a common vertex. That is satisfied. Next. Just one second. Just one second. 1 second. Yeah. You got it right, actually. Yes. I'll leave that to you to explain. I'm not coming to that point. I'll stop before that and you can continue. Which are the arms of angle 1? Arms of angle 1, OB and OC. And which are the arms of angle 2? OA and OC. Okay. Now check if they have a common arm. Yes, they have a common arm, OC. Now what's the next thing you'll have to check? So they have a common vertex, they have a common arm. Next, what should you check? The non-common arms. Which are the non-common arms? These are the two non-common arms. Non-common arms. These are the two non-common arms. Yeah, Deepthi, continue. Where do the non-common arms lie?
They have to lie on either side of the common arm.
But how are they here in this figure?
Ma'am, but here OA is before OC and OB is also before OC.
Correct. So they lie on the same side. Both the rays, they lie on the same side of the common arm. So now check where ray OB and OA lies. See here. Common arm is OC. This is the common arm. Correct. And where are the non-common arms? OB and OA. OB and OA. Both of them are like above. They're on the same side. Yeah. So angle 1 and angle 2 are not adjacent angles because they have a common vertex. They have a common arm. But their non-common arms, they lie on the same side of the common arm. The non-common arms must lie on either sides. So here the common arm is what? OC is the common arm. Where are the non-common arms? OB and OA. Both of them are on the same side. See, this is the this is the common arm. Both of them are like above. I think I had marked like this. One is OB and OC, yeah. OA and OC, correct, yeah. So angle 1 and angle 2, they have a common vertex O, a common arm OC. OC is the common arm. So these two are the non-common arms. These two are the non-common arms. Where do the non-common arms lie? They lie on the same side. This is the common arm. On the same side, we have the non-common arms. So they are not adjacent angles because the non-common arms must lie on either sides, opposite sides. Like one should be above, one should be below. Or one should be to the left, the other to the right, like that. See, in this figure, this is the common arm. And these are the non-common arms. These are the non-common arms. This is the common arm. And these are the non-common arms. You see that they are on either sides of the common arm. So in this figure, angle 1 and angle 2 are adjacent angles. Get that? So here, when I share the images, you can see it's all explained. What we discussed, you can see it here. So when the figure is not marked, you need to mark it so that you can express yourself. If there are no markings, it's difficult to express yourself. You can mark and okay, so you can read it when you do your homework. So now tell me, two angles are said to be adjacent angles if first they have a common vertex, they have a common arm. Yeah, the non-common arms must be on either sides of the common arm. The non-common arms must be on either sides of the common arm. Memorize that, okay? Well, now you've understood. So now you should memorize. Read as it is from there. Memorizing is a skill. When you mugging is different, memorizing is different. Mugging is you don't understand the content, but you just put it in your mind without understanding what it means. Memorizing is a skill. It's not easy to memorize. You can memorize. Yeah, when you memorize, you actually understand. And then you want to, express it using the same words. All these words are new, right? The way it is expressed is new. Only when you memorize, you can answer it as beautifully as it is here. Yeah, so all these exercises you should help yourself. I've explained here. You can read and understand all this, okay? Everything is here. Because if we discuss all this, then I'll not allow you to think. So when you do all this as a part of your homework, I'll be sharing all these images. When you do this, don't blindly copy. It's not to complete your classwork. Go through, understand, and then complete your class. Hello, children. Sorry, darling. Yeah, I remember. Yeah. No. Next is linear pair of angles. What we just discussed? Adjacent angles. Now, adjacent angles. This is linear pair of angles, not from the beginning. Once again. Yeah. Linear pair of angles. Linear pair of angles. Okay. Linear pair of angles. Now, two adjacent angles. If a pair of angles form a linear pair, they should first be adjacent angles. They must first be adjacent angles. If two angles form a linear pair, they must first be adjacent angles. Okay. So all those conditions must be there. They must have a common vertex, common arm, but the non-common arms must go in the opposite directions. they must be opposite rays. The non-common arms must be opposite rays. Like if one arm goes like this, the other one should go like this. Okay, I'll see if I have a figure. Yeah, see here. Linear pair of angles. Two adjacent angles are said to form a linear pair if their non-common arms are opposite rays. If their non-common arms are opposite rays. If one non-common arm goes like this, the other non-common arm must go like this. Opposite directions, like one is going towards east means the other one should go towards west. One is going towards north, the other should go towards south. Opposite rays, opposite directions, east, west, not south, like that. See, if one ray is going like this, the other ray should go like this. Opposite rays. Opposite sides. Yeah. Okay. So see the figure here. The two adjacent angles are said to form a linear pair if their non-common arms are opposite rays. Okay. So see here, angle 1 and angle 2, they are adjacent angles. Angle 1 and angle 2, they are adjacent angles because they have a common vertex, they have a common arm. We are talking about adjacent angles, okay? So they have a common vertex, they have a common arm, and these non-common arms, they lie on either sides of the common arm. So they are adjacent angles. And also the non-common arms, they are opposite rays. So they are also adjacent angles. Sorry. So they are also linear pair of angles. They are adjacent angles. They can also be called a linear pair of angles because their non-common arms are opposite rays. That's why the definition is two adjacent angles, not two angles. Two adjacent angles are said to form a linear pair. So linear pair of angles are adjacent angles, but all adjacent angles need not form a linear pair. Adjacent angles need not form a linear pair, but if you have a linear pair of angles, then they are definitely adjacent angles. When we revise it again in the next class, when we keep using these terms, it will become easy for you. When you see things for the first time, it will be like, it's so difficult how to remember. I'll forget. Yeah, it happens with everybody. Okay. Yeah. Two adjacent angles are said to form a linear pair if their non-common arms are opposite rays. So in this figure, O is the common vertex, OB is the common arm. The non-common arms are OC and OA. They lie on either sides of OB, of the common arm OB, and they are also opposite rays. OC is in this direction, like OC is going towards west, OA is going towards east. So they also form a linear pair. They are adjacent angles and they form a linear pair because their non-common arms are opposite rays. That's it. So in this figure, you see the non-common arms are OR and OP. See the direction. This is going like east, no, but this is not going towards west. This is somewhere between north and west. It's going northwest. They're not opposite rays. So they are adjacent angles, but they, yeah.
Yeah, I have a doubt.
You have a doubt?
Yes, ma'am.
Yeah.
Ma'am, it says that linear pair of angles are supplementary. So are they always supplementary or are in some cases are they supplementary?
No, what did you ask after supplementary? Yeah, linear pair of angles are supplementary angles, yes.
Are they always supplementary or only in some cases?
No, they're always supplementary. Linear pair of angles are always supplementary. Adjacent angles may be supplementary. Adjacent angles may or adjacent angles can also be complementary, like in this case. Yes. Here, this case. Angle 1, angle 2. Okay, angle 1 and angle 2. They are adjacent angles and they're complementary. Angle 1 plus angle 2 is 90 degrees. Adjacent angles can be complementary. Adjacent angles can be supplementary. See, they can be, yeah, see like this, angle 1, angle 2. Now, angle 1 and angle 2 are adjacent angles, but their sum is less than 90. The sum of two adjacent angles can be acute. The sum of two adjacent angles, when you add the two adjacent angles, the sum can be acute, the sum can be 90 degrees, the sum can be 180 degrees, can be more than 180 also. So adjacent angles, all adjacent angles need not be supplementary, but adjacent angles can be supplementary. Linear pair of angles are always supplementary. Linear pair of angles. Angle 1 plus angle 2 is 180. Angle 1 plus angle 2 is 180 degrees. So in this figure, angle 1 and angle 2. In this figure, angle 1 and angle 2 are adjacent angles that form a linear pair because they are non-common arms OA and OB. OA and OB, they are opposite rays. That's the reason. Angle 1 and angle 2 are adjacent angles. Angle 1 and angle 2, they are adjacent angles that form a linear pair because their non-common arms OA and OB. OA and OB are the non-common arms. They are opposite rays because one is going towards east, the other towards west. Yeah. Sit down, sit down. Sit down, sit down. That form a linear pair? Oh, here you say, okay. So adjacent angles form a linear pair and are supplementary. And are supplementary meaning they form a linear pair and are supplementary meaning they add up to 180 degrees. Linear pair of angles are always supplementary. No, they cannot. No, no, no. Linear pair of angles are always supplementary. Linear pair of angles are always supplementary. Linear pair of angles are always supplementary. Adjacent angles can be anything. Adjacent angles can be anything. All right. Can be anything, meaning the sum of two adjacent angles can be less than 90, can be 90, can be more than 90, can be equal to 180, anything. When the sum of two adjacent angles is equal to 180, they form a linear pair. When the sum of two adjacent angles is equal to 180 degrees, they form a linear pair. If it's a linear pair, the sum of the two angles is 180 degrees. When you have adjacent angles and their sum is 180, that means they form a linear pair. If two adjacent angles form a linear pair, then their sum is 180 degrees. But in the second one, angle 1 and angle 2, in the second one, angle 1 and angle 2, they are adjacent angles. They are adjacent angles, but they don't form a linear pair because they're non-common arms. OR and OP, they're non-common arms OR and OP. They're on either sides, but they're not opposite rays. They're adjacent angles. Yeah. Because they're not opposite rays. Opposite rays meaning, see the direction of this ray? East. What's the what should be the direction of the other ray? West. But where is it actually? North and west. It's somewhere, it's northwest. Which are opposite, which are the opposite directions? East and west. Yeah. So if it is northwest, it should be southeast. Like this. This one and this one, they are opposite rays. Yeah. So here, this ray and this ray, they're not opposite rays. They're on either sides of the common arm, but they're not opposite rays. Yeah. One second. One second. Yeah. We just have one more term to understand. Okay, vertically opposite angles. It's here. Okay. So when two lines intersect each other, vertically opposite angles are formed. See, when two lines intersect like this, four angles are formed. Angle 1, angle 2, angle 3, angle 4. When two lines intersect at a point, so this is the point of intersection. Okay, so let's say this is line L and this is line M. So lines L and M intersect at the point O. Okay, when two lines intersect at a point, four angles are formed. I've numbered it, angle 1, 2, 3, and 4. Now, this is when vertically opposite angles are formed. Vertically opposite angles are formed when two lines intersect at a point. When are vertically opposite angles formed? When two lines intersect at a point. Okay, so these are the four angles. Angle 1 and angle 3 are vertically opposite angles and they're equal in measure. They're equal. Similarly, angle 2 and angle 4. Angle 2 and angle 4, they are vertically opposite angles and they'll be equal in measure. Angle 1 is equal to angle 3. Angle 1 and angle 3 are vertically opposite angles. And they'll have the same measure. Angle 1 is equal to angle 3. Similarly, angle 2 and angle 4, they are vertically opposite angles. They'll have the same measure. Angle 2 is equal to angle 4. So when are vertically opposite angles formed? When two lines intersect at a point. When two lines intersect at a point, vertically opposite angles are formed. How many angles are formed in total? 1, 2, 3, 4. But how many pairs of vertically opposite angles can you see here? How many pairs? Two pairs. In this figure, you can see two pairs of vertically opposite angles. One pair is angle 1 and angle 3, they are equal. And the other, angle 2 and angle 4, they are vertically opposite and they are equal. Angle 1 is equal to angle 3, angle 2 is equal to angle 4. Two pairs of angles are formed. All right, they are called vertically opposite angles. All right, children? Okay, so I'll let you know how we shall be completing the notes. I'll let you know on WhatsApp. Maybe we can connect online and I'll present it. You can stay in the class and complete. That way, I'll ensure that all of you are completing. If I share the notes, I can't make sure that all of you complete on time. All right, I'll post the details on WhatsApp. All right, children. So that's it for today's session. Thank you so much. Yeah. Thank you, Deepthi.
Thank you, ma'am. Bye, ma'am. Thank you.
Thank you. See you.